Have you ever wondered about the difference between weather and climate? What is climate? What factors combine to make climate? You can probably name most of them already. Temperature, wind, rainfall, soil, vegetation, the shape of the land. These and others we haven't named interact to create the climate where you are. The kind of house you live in, the clothes you wear, and even the games you play are determined by climate. North Carolina is blessed with a range of climates, from the high mountainous regions to the coastal plain. The climate of North Carolina can be divided into 3 zones that generally match the coastal plain, Piedmont, and mountain regions of the state. As you can see, we are in the coastal zone. This zone includes the beaches and sounds of the entire coast, from Calabash to Corolla, and from Cape Hatteras to Englehart. It is unique because the ocean is the controlling agent. Continual winds and the large expanses of water combine to limit the kinds of plants that will grow on the beaches, barrier islands, and shorelines of the sounds. The most obvious effects occur along the beach and in the dunes, where only the hardiest of plants survive. Salt marsh grass, sea oats, and yaupon are the principal plant species that occupy this very special ecosystem. But if we move into the coastal plain only a short distance from the ocean, we find a different climate. There are few hills of any size on this broad, gently sloping band of sandy soil, and because of its flatness, the temperatures tend to be about the same over the entire plain, except where the ocean or sounds act as a moderating influence. To help us understand the plant communities in the major climatic zones of the state, let's listen to an expert. Dr. Hollis Rogers has studied and taught in the Carolinas and Tennessee for more than 25 years. We followed him as he talked to his botany class about how climate affects plants. I think you will discover, as we did, that he has a unique understanding and love for North Carolina.
We are starting this run on North Carolina in a North Carolina rainstorm, as you see. Well, not a rainstorm, just a drizzle this time. The vegetation of North Carolina is controlled by water. Theoretically, the entire state would be covered with a deciduous forest. Our pines here are the result of a slight change in temperature being down in the southeast, the soil conditions that lets the water seep down and get away on the sand hills, and the fact that this condition and that rains are scarce a certain part of the year and heavy at others grows a bunch of grass and weeds on the soil, and then it dries up and burns. So here in the sand hills, we have 2 real expressions. We have the longleaf pines that you see all around you, and then down here, the evergreen shrub bog, and in there you have the sweet bay, a number of hollies, and these plants with their roots underwater, when the fire does come through, the fire raises up and leaves them. Then, as a result of this situation, we have this condition right behind me here, the evergreen shrub bog. And it's on the edge between the evergreen shrub bog and the longleaf pine on the sand hills that we find the majority of these famous and world sought after to see the insectivorous plants. The Venus flytrap, the most famous one, then the pitcher plants, the sundews, drosera, pinguicula, the bladderworts, the whole bunch of them. Now, do we have any questions from the group?
Doctor, other than right here, where can you find Venus flytraps?
Well, the Venus flytrap species is really a unique one. Actually, every native Venus flytrap plant in the world grows within 100 miles of Wilmington. We are about 10 miles south of Wilmington, a little south of the center. The center of them is just north of Wilmington. Now, this is a climatic situation, the soil, the weather, all put together, and the people who take Venus flytraps other places are just destroying the plant because they will not survive only under the conditions that exist here. And it's a very sad thing to move them out. And that's the reason that North Carolina has very strict laws protecting Venus flytraps. They can only be moved by licensed people for scientific purposes. And that's the reason I've told all of you that you can't take any home with you. You'll kill them if you take them home with you.
The mild climate of the southern coastal plain, with almost 9 months of frost-free weather, an average annual temperature of 65 degrees, and about 50 inches of rainfall, changes very little as we move north along the coastal plain. But the elevation and drainage do change. And as a result, the northeastern coastal plain is a largely swampy region. The swamps modify the regional climate by reducing the extremes of temperature, and they also produce a unique freshwater plant community.
We're in Gates County, North Carolina now, on Merchant's Mill Pond. This is really a historic spot. Here we can read the history of the past 2,000 years, because some of our cypress trees in this swamp have been aged to be slightly over 2,000 years of age. There has been swamps and ponds here in this area throughout this period. It's very probable that the first engineers and the first ponds were the beavers. The beavers would have dammed Bennett's Creek, which incidentally drains approximately 75 square miles of North Carolina and Virginia, funneling the excess of the 48 inches of annual precipitation down into this stream and ultimately into this pond that we are visiting right now. The vegetation here, where the water stands and has stood periodically for 2,000 years, constantly for 200 years, has resulted in a very special kind of plants. We have cypress trees, which make up the majority of the vegetation in here, but among the cypress trees are many excellent examples of the water gum, the tupelo, which can also tolerate this area. The shape of the base of the trees shows one rather critical change that must be explained. It seems that about 200 years ago, our forefathers, needing power to run their grain mills, built a dam on Bennett's Creek to hold the water. They put in a power plant. They ground the grain for food, and this dam built by man replaced the periodic and ever-changing dams that the beaver would have had here. And that changed the complexion of the face of the land, and the buttress of these trees ran up to show the level of the water as it stood during that period of time. Then, more than 100 years later, the road people decided to use the dam for a highway. And in order to expedite their work, they lowered this water level about 4 feet. which means that there are two sets of watermarks on the trees. One at the top of the buttress, and then it flares out, tapers down, and presently this water level is within 6 inches of where it stands year-round. It has been slightly wet recently. The water in the lake is up just a little. There is a relatively large amount of water going through the spillway at the dam, but this is just about the way it stands.
The fall line zone that separates the flat, sloping coastal plain from the rolling hills of the Piedmont also marks a change in climate. From here to the mountains, there are about 5.5 months of freezing temperatures. The average temperature is about 5 degrees lower, mostly because of the higher altitude. Snow, sleet, and freezing rain average 5 to 8 inches a year in the foothills of the mountains, but occur only in trace amounts at the edge of the coastal plain. The rolling land of the Piedmont produces wide differences in local climate. These differences, called microclimates, often occur on north and south-facing slopes of stream valleys. The result may be mountain plants on the north-facing slopes and coastal plants just across the valley on the slopes which face to the south. Not all examples of microclimates occur in stream valleys. Perhaps you can find one near your home.
We have moved some 300 miles west. We have climbed 1,700 feet in altitude, and we have come into a totally different world of climate and vegetation since moving from Merchant's Mill Pond in Gates County for the last fill. This area is covered with an oak hickory forest. The trees here are quite different than the ones we saw on the coastal plain, on the sand hills, or in the mill pond. The principal difference is brought about by the difference in the water as it is retained in or on the soil. There is some temperature variation, exposure differences that come in, but basically the difference is where the water is and how it's available. Here at Hanging Rock State Park, in the upper Piedmont, almost the foothills of the mountains, we are still getting approximately 48 inches of annual precipitation. At this point, some 2 feet of snow is melted to add in to that 48 inches of water. The principal difference here is that erosion of this Piedmont Plateau has produced hills and valleys, very critical, very steep in places. You have hillsides and floodplains along the streams, and the water here that is available to the trees must be maintained in the soil. The climax forest here should consist of deciduous hardwood trees. At this altitude, it will be principally oaks and hickories. One of the principal ones on the hillside surrounding me is white oak. There is some scarlet oak, chestnut oak, northern red oak. These trees form an almost total canopy over the land. There are understory shrubs and trees to fill in below, but the big trees, if left here, almost shade out the others. So we have a moist, a rather humid environment under these trees. This forest maintains itself. It, if undisturbed, will stay oak and hickory for hundreds and hundreds of years, with the old trees falling out and new ones taking their places. Here, the soil stays moist, making the possibility of wildfire much less than on the coastal plain. It is now a forest like this, with soil of this kind, protecting the forest floor, that is our North Carolina's greatest water storage potential. The 48 inches of rain that falls here takes months to get down to form the streams that run out of the Piedmont into the coastal plain. This water is the water that you and I need for drinking, for our industries, for our way of life.
The Blue Ridge marks the end of the Piedmont and the beginning of the mountains. The rise to the mountains marks not only a change in altitude, but also an abrupt change in climate. The precipitation, which is remarkably uniform over the rest of the state, varies widely in this region, from a low of 45 inches to a high of 75 inches per year. The mountainous terrain is primarily responsible. Winds bearing moisture blowing in from the west are lifted by the mountains, cooled, and unload their excess water on the mountain slopes. The temperatures also become cooler with increasing altitude, and in winter, snow is common.
We're here at 4,500 feet above sea level in the greatest forest the eastern United States has ever been able to produce. It is a magnificent forest with towering oaks, maples, some tulip trees, hemlock from below meets the red spruce from above, and both those species are here beside me, the evergreen species. This forest is the result of lower temperature and higher rainfall. About twice as much precipitation, with an enormous part of that coming in snowfall in the winter months, and an average temperature some 15 degrees below the average temperature of the upper Piedmont. This is the region that has produced our greatest lumber resources, and this is the region and the soil in this region that stores the water that produces our reservoir of water for our industries, our cities, and those places down in the Piedmont and down to the coastal plain.
As we move up through the mountains, the weather becomes harsher. Most people live in the mountain valleys to avoid the worst that Mother Nature has to offer. But the plants reflect the change. As we get higher and higher, the oaks and maples begin to disappear and are replaced by red spruce, which in turn gives way to Fraser fir on the highest peaks.
All right, we've made it. Here we are on Mount Mitchell. Right now I'm standing over a mile above sea level at some 6,500 feet above sea level. You notice even here now, in the middle of June, I'm wearing a heavy coat and I'm cold. The temperature last night around here dropped to in the 30s. It will get up into the 60s today if the clouds disappear and the sun comes out. Otherwise, it will be down in the 50s. The sun is shining up there, but the cold air here is causing the warm, moist air that's coming in to condense and form clouds right around us. You can see from the vegetation the weather has changed terrifically from the previous scenes that we have done. The weather here is quite critical. We get up to 150 inches of snow per winter. The temperature drops as low, has been recorded as low as 29 degrees below zero Fahrenheit. And the rainfall is up. The annual precipitation is between 80 and 100 inches. And you can see around me that there are none of the oak, hickory, beech, maple trees at all. This is a Canadian zone. These are the trees that can take this critical weather situation. And that's the reason we have ended here after starting at the coast. This weather will just prohibit the trees like grow in the lower elevations from living. They may be planted, but the winter will kill them when the temperature drops and the wind comes up. The animals here are similarly adjusted. The squirrels are a different species of squirrels than the ones in the lowlands. We have North Carolina boomers here. There's also skunk, deer, bear, and some of them move up and down the mountains, some stay regardless of what the weather may do. The same plants, many of the same animals that you would find if you went into the middle of Canada at sea level. The change is due to the elevation, the altitude. This is shown very nicely by the Fraser fir trees around me here. It was the presence of these trees that led Dr. Elisha Mitchell to do his measurements, which determined Mount Mitchell to be the highest mountain in the eastern United States, the highest mountain any place east of the Rocky Mountains.
Within its boundaries, North Carolina's climate varies from subtropical on the southeastern coast to Canadian on the highest mountain peaks. As is true in many other states, the major reason for the change is altitude. The elevation changes from sea level to more than 6,500 feet. Because the average temperature drops about 3 degrees with every 1,000 feet of change in height, there is an 18-degree difference in average temperature from the coast to the mountains. But, as we have seen, wind, the shape of the land, and the kind and amount of precipitation play an important role in determining our climate. The variety of climate and the resulting variety of plants and possible activities make the eastern coast of the United States one of the most varied and pleasant living places in North America.